Hi everybody. In this video I'm going to talk about how to set up function tables for evaluating basic linear functions. So the steps to doing this include, number one, substituting input values. Now, input values are sometimes provided, sometimes they're not. If they're not provided, then you have to choose your own. And there is a strategy to doing this. It depends on the function that you're working with, and we're going to look at two examples of that. So after you substitute, you then simplify using the order of operations. Number two would be make an ordered pair using your input choice or whatever input is given to you, and then your output would be your f of x or your y. And then number three would be to plot each pair of ordered pairs that you create from your table, and then go ahead and generate your graph. So let's look at example one. So in example one, we have f of x is equal to negative 2x. And the table I like to set up is broken up into these categories. So you can see that on the left side, I have an input side. I do have some pre-set values for the input, but you're free to choose whatever you want. The function itself goes next. And this is where I generally do all my evaluating, showing my work, and etc. The result of that would be the output that goes in the third column, and that's where I simply put my my f of x or my y, and then in the final column I put my ordered pair combination, which is the input and the f of x or the y as a combination. That's my ordered pair, and each ordered pair will then later turn into a point on my graph, or on my coordinate plane, which will be part of my graph. So with that said, here we go. So first, my input is negative 2. Now, what I'm going to do with this is I'm going to substitute this into my x. So this is here a negative 2. And then over here, I need to show that this negative 2 from my function is being multiplied by my input of negative 2. And that's going to provide me with an answer of positive 4. That then goes over here as my output, so 4. And then my order pair, my first order pair, is my input, which was the negative 2, followed by my output, which was the 4. Okay? They all work the same way. But for the future inputs, I'm not going to write f of that input. I'm just going to go right into the substitution and then the answer. So for my next input, which is a 3, I'm going to have negative 2 times 3, and that will be negative 6. Now negative 6 is my next output, so that goes there. That's a value of f of x or my y, and then I get 3 comma negative 6. Following the pattern, I multiply negative 2 times 4, which is negative 8. That's my next output, 4 negative 8. And then over here, this would be negative 2 times 7, negative 14. That's my last output. So 7 and negative 14. Now, I did mention earlier that there would be strategies I would talk to you about. In general, you want to choose input values that are not too big or too small in either direction of the origin. The reason for that is because you need to allow for space to actually place your points on the coordinate plane. So 7 is actually a rather large input value for this function because I'm multiplying that with negative 2, and as you can see, I got a negative 14 over here. So I'm going to have to actually go down quite a bit on the coordinate plane. I don't usually do that, but I thought I would just illustrate. You can pick any input you want. Just make sure that it does fit. If you want to use a big coordinate plane and it's okay with your teacher, knock yourself out. So now that I have a complete table, what I then can do is take each of these ordered pairs that you see over here, and they each turn into a point. Now, I've already actually done this, and it looks like this. So you can see that every point that you see on the left side here corresponds to a point on the right side. And the result of that, when I join all these points together, is I get a continuous line to infinity in both directions. And that corresponds to the fact that my function itself is a linear function, and as such, it is infinite in both directions, just like a number line. Okay, so that's my first example. Let's go ahead and look at the second example. And in my second example, I did make a note before diving right in. This function is a fraction. It has a fraction as a multiplier to my input. Fractions, I notice, tend to give people a bit of a headache, and so there's a bit of a trick around that, so it's easier to work with. And the trick is, when you have a function that has a fraction, and you have to pick values for an input to multiply against that fraction, what you want to do is you want to choose, first of all, 0. If you are able to choose 0, use it, because 0 makes anything into 0 when you multiply. So it's easy, it's painless, it's quick, and it gives you a real simple, quick ordered pair. The other values after that could be either positive or negative, but whatever you choose, my advice is pick values that are divisible by your denominator. So if you look over here, my denominator is a 3. And so what I want to do is I want to choose input numbers that I know can be divided by 3 nicely. It doesn't matter if my input is a positive or negative, it just has to be able to be divided by 3. So some small ones to work with would be -3 and +6. I could have also chosen +3, but I chose +6. So with that, let's go ahead and get right into this, and I'll show you how this works. So as before, with my other example, this would be f of -3. This is now going to be 2/3 times, and to make this easier to multiply, I'm going to put the -3 over a 1. So it's just easier to multiply fraction with fraction. So depending on how you learn to multiply fractions, either you will think to yourself that these two 3's here will turn into a -1, but if you don't know that technique, then what you can do is simply multiply straight across. It does take a little bit more work, but it does give you the same result. This would be -6 over +3. And again, you're just multiplying side to side here. And then -6 divided by 3 would be -2. So my first output is a -2. That's my f of x. And then my first order pair is -3 and -2. So continuing on with 6, I'm not going to put f of 6. I'm just going to go ahead and do the straight substitution. This is going to be 2/3 times 6/1. And again, you're multiplying straight across. So what you get from that would be 12 divided by 3, which is 4. That's my output. And here's my order pair, 6, 4, input, output. The last one, as I said, is 0. Should be very, you should already be able to figure this out mentally, I'm sure. But just to show you the work, it's 2/3 times 0. No need to put 0 over 1. 0 is fine. And because anything times 0 is just 0, this output is a 0. So that goes there. And my order pair is at the origin. So now that I have my 3 order pairs, I can go ahead and show you what this thing looks like. So like before, I've already done this, and this is what it looks like. So you can see right here is my function. Here's my function. And the function is drawn as my red line. And on the red line, I have the points that correspond to the order pairs that come straight from the table. So here's my first one there, my second one, my origin, and then my 6, 4. And as before, this is a line that's continuous in both directions, and it is infinite in both directions because it stems from a linear function. So I hope this video helped you better understand how to both select values for an input, how to evaluate a function using those inputs, and how to transfer those input-output combinations into points that create a graph. So please stop by, leave a comment, and as always, thanks for watching. Bye-bye.